My name is Devendra Singh. I am teaching you solution, dilute solution and colligative properties, relation between depression in freezing point and molecular weight of the solute. Freezing point of a substance is the temperature at which the solid and liquid state coexist. That is, the two states have the same vapor pressure. The presence of a non-volatile solute lowers the vapor pressure of the solution. Thus, liquid and solid state will have equal vapor pressure at a much lower temperature. Hence, there is a depression in freezing point. In other words, the freezing point of a solution is lower than that of the pure solvent, as clear from the figure. The curve AB represents the vapor pressure curve of pure solvent. At point A, solvent coexists with the liquid state on page number 1. On page number 2, the temperature corresponding to the point A gives the freezing point of the solvent. Similarly, curve CD represents the vapor pressure curve of the solution, in which point D corresponds to two states of the solvent existing simultaneously in the solution. Thus, temperature corresponding to point D is the freezing point of the solution, which is clearly lower than the freezing point of a pure solvent. Hence, there is a depression in the freezing point given by delta Tf. Delta Tf is equal to T naught F minus Tf. It has been found that depression in the freezing point is proportional to molar concentration of the solvent in the solution. Molarity is given below. Delta Tf is equal to Kf into molarity, where Kf is constant known as molar depression constant or cryoscopic constant of the solvent. On page number 3, if molarity is equal to 1, then delta Tf is equal to Kf. Hence, molar depression constant may be defined as the depression in the freezing point when 1 mole of the solute is dissolved in 1000 gram of the solvent. Molecular mass of non-volatile solute, since molarity is equal to 1000 into small w upon capital W into small m, delta Tf is equal to Kf into 1000 into small w divided by capital W into small m, or small m is equal to 1000 into Kf into small w divided by capital W into delta Tf. Here, delta Tf is equal to depression in freezing point. Kf is equal to molar depression constant or cryoscopic constant. Small w is equal to mass of solute in grams. Small m is equal to molecular mass of the solute. Capital W is equal to mass of solvent in grams on page number 3. On page number 4, plot of vapor pressure versus temperature graph given. In the x-axis per temperature at Tf, T naught F is given. Difference T naught F minus Tf is equal to delta Tf, and vapor pressure on the y-axis. Pure solvent curve is equal to AB shown, and solution curve is equal to CD shown. Vapor pressure decreases of the solution on the page number 4.